Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to start with the chapter number 14, that is operators or the operations that is used in C language. That is, I'm continuing with the same module, that is procedure programming module. In the last class we have discussed about what is a language, what are the issues that is available in the input and output. That is, what are the criteria that is available when we give the input and when we take the output in the C language. So let's take a quick review what we have covered in the last class, then starting with the next topic, that is the today's topic, that is operations or the operators that is used in C language. That is, what are the types of operator that is used in C language. So we have started, or we have discussed about chapter number 13, that is more issues in input and output. That is, what are the issues, what are the more issues that is available when we give the input and when we take the output in the C language with the help of the file. In this we have discussed about these chapters, about these topics like ARGC, ARGB, detecting errors, standard input-output devices, input-output redirection, that is redirecting the output, input, and redirecting the input and the outputs both. That is, at the same time we have to redirect the input, at the same time we have to redirect the output. So we have started with the first topic, that is the ARGC and the ARGB. So how to use the ARGC and how to use the ARGB, what is the advantage of using them? In simple terms, whenever we have to compile the code in the command prompt, in the DOS prompt, in the MS-DOS, so we have to use the ARGC and the ARGB commands. These are known as command line arguments. Why they are known as command line argument? Because we have to give the commands on the command line. That is, the command line means on the MS-DOS. That's why it is known as, or they are known as command line arguments. We have discussed how to give the command line argument using ARGC and the ARGB. This is the second improvement. These are the improvement that is made when we use the ARGC and the ARGB. Means, what is the improvement, what is the advantage that is used in this one? The first improvement is very simple. In MS-DOS, the executable file is can be treated in Turbo C or the C++ by using the F9 to compile the program. That is, whenever we use the Turbo C++ in MS-DOS, that is, whenever we compile the code in MS-DOS, simple press the F9 key for compiling the code. In the same way, F7 key is used to compile the code again and again every time. The second improvement, that it is possible to pass the source file and the target file to the function main only. This is the program that we discussed. That is how to use the ARGC and how to use the ARGB. Generally, ARGC contains, or it is a part of the, or it is a type of the data type, that is the integer, while ARGB is a type of the string. So in simple terms, ARGC is used for calculating the number of arguments, number of characters, while ARGB is used to display the string, that is a collection of characters. So this is ARGC, that is in integer, and ARGB, that is in string, that is ARGB. Then in this we also use the fgetC function for getting into the memory and fputC function for putting into the memory, that is a puts function. Right. Then fclose is used for closing the file by using the file pointer, that is fs and the ft. This is the argument that we pass on the the command prompt are known as command line argument. That is, ARGC and the ARGB are known as command line arguments. That is, out of this, ARGB is the array of pointers to the string, while ARGC is an int whose value is equal to the number of string that is equal or that we stored for the ARGB. Then ARGB 0, ARGB 1, and so on. So it starts with ARGB 0, then 1, then 2, and so on. The argument ARGC is set to the number of strings given on the command line. For example, in our sample program, if at the command prompt we give this one, file copy pr1.c, pr2.c, then ARGB or ARGC would contain 3. Then this shows argv0, argv1, argv2. That contains the base address of the string file copy, then pr1.c, then pr2.c. That is, file copy is also stored, or it is also having the base address that is available in the argv0. Then rest of the program is same as the earlier file copy program. This says what are the advantages that we use, or that is given when we use the argc and the argv in the command in the file. This is an example that is discussed over here. Now, next topic that we discuss is how to detect the errors when we read and when we write the file or data into the files of the C program. One function is used that is used for detecting the error. That function is known as ferror function, or the ferror. So ferror is a function that is used to detect the errors in reading and writing. So this is the standard library function, that is the ferror, that reports any error that might have occurred during a read-write operation. That is, whenever we have to check the error, which function is used? That is, the ferror function is used for checking the read or write operations on the disk. It returns a 0 if the read-write is successful. That is, if the read is successful, we have to read the data, and we are able to write the data, that it returns the 0. That is successful. That is, the standard library function is valid. That is a ferror function. In case of and returns the non-zero values, that is either 1, 2. That is a non-zero value in case of a failure. So in case of a correct, that is in case of a true, it is given a 0. In case of a non-correct, it is given a -1, 2, anything except the 0. This is the example that shows how to use the ferror function. This ferror is used to display the or detecting the errors when we give the input and the output. So whenever we give the input and the output, this must be displayed on the screen. This is the explanation of the program that is given. One more thing, this is given, that is a new, we can also use the p-error function, which prints the error message specified by the compiler. That is, we are also able to use one more function, that is a p-error function, that prints the error message that is specified by the compiler. That is, whenever we have to print the error message, we have to use the library function, that is a p-error function. Then we have discussed about next thing, that is the standard input output devices. This is the next topic, that is how to use the standard input output devices. There are few standard input output or the standard file pointer that is used, or the standard operations that is used. That is, one is stdin, one is stdout, one is stderr. So file pointer stdin used for the standard input device, that is keyboard. stdout is used for standard output device, that is video. stderr is used for standard error device, that is also a video. So these are the three file pointer that is used whenever we use the fopen function and whenever we use the input output devices. This means these are the standard file pointer that is used in the C language. Then this is the statement, that is ch equals to fgetc stdin would read a character from the keyboard rather than from the file. Two more functions are used in MS-DOS. Which pointer functions or which standard library pointers are used? One is stdprn, one is stdaux. stdprn stands for standard printing, and next is standard auxiliary device. Then we have discussed about the program. Then this is the example that writes the character from the file to the printer. This is used for printing or for printer purpose. Then we have discussed about the input-output redirection. That is how to redirect the input and the output. That is, what is the privilege or what are the ways how we can redirect the input to the output and the output to the input. This says Most operating system incorporates a powerful feature that allows a program to read and write files even when such a capability has not been incorporated in a program. That is, most of the operating system is used or incorporate a feature that allows a program to read and write the file. That is done through a process that is known as the redirection. Normally, a C program receives its input from the standard input device, which is assumed to be keyboard, and sends the output to the video. But if redirection permits that we can get the input, we can take the output, that is also done by using the redirection. To use the redirection facility is to execute the program from the command prompt. That is, we have to use the command prompt for executing the command whenever we have to use the redirection facility. Then we have discussed how to redirect the output. This is the example how to redirect the output. These are the various explanation of the example of the code. Then we have discussed how to redirect the input. That is how to redirect the input that is given, that is redirection operation. We can also redirect the input to a program so that instead of reading a character from the keyboard, a program reads it from a file. Now let us now see how this can be done. That is how to redirect the input, that is also given in, or that is also discussed in the last class. Now both ways at once, that is, we have also discussed how to use the redirecting the input and redirecting the output at the same time. That is how at the same time we can redirect the input as well as the output. Then we will discuss about the summary. What is the summary? Why we are using these functions? These are the various questions. Now next chapter is operations on bits. That is how we perform the operations on the bits. This is the chapter number 14. So let's start with the today's session, today's topic, that is the operations on the bits. That is chapter number 14. So as the name advises, operations on the bits means what are the operations that is available on the bits. Operations means any type of operation like plus, minus, divide, multiply, less than, greater than. So these are the sorry. So these are the various operations that is available on the bits. Bits means either 0 or 1. So we have to take the bits or we have to apply the operations on the bits. The operations may be less than, greater than, less than equals to, greater than equals to, double equals to, plus, minus, divide, multiply. So it may be any operation that is available on the bits. So let's start with this one. This chapter contains multiple operators, multiple functions. One is bitwise operators. The bitwise operator contains one's complement operator, right shift operator, left shift operator, bitwise AND operator, OR operator, and the XOR operator. So these are the various bitwise operators that is used. Then this chapter also contains the show bits function. So this is the function that is used to show how many bits are occupied. Then summary, then exercise. So in this chapter nothing, or what this chapter contains only the bitwise operator that is used in the C language, that is used for operating or for performing the operations on the bits. This says so far we have dealt with the characters, integer, float, and their variations. That is till now we have covered how to use the integers, how to deal with the character, how to deal with the float and their variations. Variation means how to use the character as a string, how to use the int as a float. The smallest element in memory on which we are able to operate is yet is a byte. That is the smallest element that is available, that we perform operations on that smallest element. That smallest element is known as byte, and we operated on it by making use of the data type char. That is, whenever we have to use or whenever we have to use the byte, we use only one data type, that is a char. However, we have attempted to look within these data types to see how they are constructed out of individual bits and how these bits are manipulated. So this line says, now let us see what are the bits and how we can use the operations on the bits. Next point says, being able to operate on a bit level can be very important in programming. That is also very important how to perform the operations on the bits, especially when the program must interact directly with the hardware. This is because the programming languages are byte oriented. That is, every program are byte oriented, where the hardware tend to be bit oriented. Let us now delve inside the byte and see how it is constructed and how it can be manipulated effectively. So let's take apart a byte bit by bit. That is, we have to use the bit by bit operations. So forget about the byte. Byte is a collection of 8 bits. Now, next topic is starting with the first topic, that is bitwise operators. One of the C powerful feature. This is one of the C powerful feature that is available is a set of bit manipulation operators. That is how to use the bit manipulation operators, or how to use the bit manipulation, or how to manipulate the bits with the help of different operators. That is a C powerful feature. These permits the programmer to access and manipulate individual bits within a piece of data. That is, this enables or this makes the or permits the programmer to access and manipulate individual bits within a piece of data. The various bitwise operators that is available in C are as follows. That is, what are the operators that is used, that is available in bitwise, or that is available in C language. So these are the various operators. This is one's complement. Then there is a right shift. So this is a one's complement. Then there is a right shift. Then there is a left shift. Then bitwise AND. This is the bitwise AND operator. This is bitwise OR operator. This is bitwise XOR operator. So these are the various operators along with their meaning. So one is one's complement, then right shift, then left shift, then AND, then OR, then bitwise XOR operator. That is the exclusive OR operators. So these are the operators that is available, that we can use to perform the operations on the bits. I'm repeating again. One is first is one's complement, another one is right shift, then left shift, then bitwise AND, bitwise OR, then bitwise XOR. These operators can operate upon the integers and characters but not on the floats. This is the most important point, that these operators must operate on the or can operate on the integer and the characters but not on the real values, that is the float and the double. Before moving on to the details of the operator, let us first take a look at the bit numbering scheme in integer and characters. Bits are numbered from 0 onwards, increasing from right to the left as shown below. So these are the various operations, these are the various characters. First of all, there is a 0, then 1, then 2, 3, 4, 5, 6, 7. So these are the content from 0 to the 8. In the same way, this is the 16-bit integer. This is also starting with the 0. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this contains 16-bit integer. Throughout this discussion of bitwise operators, we are going to use a function that is known as the showBits function. That is, we are using the showBits function, but we are not going to show you the detail of the function immediately. The task of showBit is to display the binary representation of any integer or character value. That is, whenever my requirement is that I have to show the or have to display the binary representation of any integer or character array or character value, then we use the showBits function to display the binary representation of the integer as well as the character. So one important thing that you must remember, that when you use the bitwise operators, that bitwise operators can work on the integer and the characters, but not on the floats and the doubles. Right. We begin with the plain Jane example that will show bits in action. So this is the solid, or this is the basic example. First, this says, so print binary equivalent of integers using show bits function. One is starting with the main function, then int j. Int j means declaring the values, that is the j, then using the for loop, that is j equals to 0. J is left shifted, so this is the operation that is used for the left shift. So this is the left shift. So this is j left shift equals to 5, j plus plus. Printf in next line, decimal percentage d is same as binary. This is the decimal number that is same as the binary number. Then printing the value of the j. Then show bits j, that is show bits is used to print or to display the binary representation of any integer or character value. That is using the show bits, and there is a character, there is a function, there is a variable that is used, that is a j, that is the show bits j. Then this is the curly brace for the for loop, and this is the curly brace for the main function. Now this is the output. Decimal 0 is same as binary. So this is decimal 0. Why? Because first of all this is 0, then decimal 0 is same as the binary, and the value is this one. Right. That is done by using the show bits operation. Then j1, that is decimal 1 is same as binary. This is the binary equivalent of the 1. Then decimal 2 is same as, that is this is the decimal 2, that is same as the binary, that is this one. That is same as the binary, this one. Then decimal 3 is same as the binary, this one. Then 4, then 5. Why it is 5? Because it is left shifting, that is equals to the 5. So it is equal, or it left shifts the value, and it left shift up to the 5. So it starts with 0, it ending with the 5. And then j plus plus means every time it is incremented 1 by 1. Now let us explore the various bitwise operators one by one. So this diagram simply shows how to use the show bits function to display the binary representation. So this is the show bits. This helps you to represent the binary representation. So this 1 will be represented in binary in this way. 2 will be represented in binary in this way. 3, 4, 5, 6. That will be represented in binary in this way. That is the show bits, this one. This is the 1, this is the 2, this is the 3, 4, 4, 5. So this is the binary representation. Now let us see the bitwise operators one by one. The first operator is ones complement operator. That is, whenever we have to calculate the ones complement, means reversing the bits. So ones complement is calculated by reversing the bits. For example, 1 becomes 0 and 0 becomes 1. So on taking ones complement of a number, all ones present in the number are changed to the zeros, and all zeros are changed to the ones. That is, whenever we take the ones complement, all the ones that is present in the number are changed to the zeros, and all zeros are changed to the ones. For example, ones complement of 1010 is 0101. That is, 1 is changed to the 0 and 0 is changed to the 1. Similarly, ones complement of 1111 is 0000. Note that here when we talk of a number, we are talking of the binary equivalent of the number. Therefore, ones complement of 65 means ones complement of this, this, this and this, which is the binary representation of 65. So whenever a number is given and whenever we have to calculate the ones complement, so first of all that number must be converted into the binary form. Olisam, do you know how to convert into the binary form from decimal to binary? Do you know how to convert uh, decimal to the binary? Okay, tell me the procedure. You can try. If you think you can try, so if you are able to get it, or if you think that I will explain, then I will explain you. So please tell me whether I explain or whether you know how to convert into the binary. Okay, I will explain you. Suppose I have to use, or suppose I have to convert this into the binary. Uh, 46 into the binary. Suppose my target is to convert, first of all, let's take the small number, 4 into the binary. So it is divided by 2. This is 2. 2 multiplied 2 is 4. The remainder is 0. Right. Now, this is 2. This is 1. The remainder is 0. Again, going to next part. This is 2. This is 0. That is, whenever we have to use the 1, it is divided by 2. So 2 multiplied by 0 is 0. The remainder is 1. How remainder? When 1 is the when 1 minus 0 is 1. So this is a 1. Now the binary equivalent will return in this form, from bottom to the top, that is 1 0 0. So 4 is converted into, that is the equivalent of 4 is 1 0 0, and there is a base 2. This is the base 2 and this is the base 10. Why 10? Because this is in decimal form, this is in binary form. Let's take example of new one. For example, 43, right? We have to use, first of all, calculate 43. So first is 2, 2 2 ja 4, that is 2 multiplied 2 is 4. This is 2 multiply 1 is 2, the remainder is 1. Again 2 1 0, the remainder is 1. Then 2 5, remainder is 0. Then 2 2, the remainder is 1. Then 2 1, remainder is 0. Then 2 0, and the remainder is 1. So this will written as in this form. So this is 43 equals to 1 0 1 0 1 1 base 2. So this is 1 0 1 0 1 1 base 2. So this is the binary equivalent of the number, that is 43 number, right? So this is how we can calculate, or how the computer will calculate how the binary decimal number is converted into the binary form. Let's take one more example, that is 65 example only. This is 65, right? So this is 2 3 2, this is 1, this is 1 6, this is 0, then 2 8, this is 0, then 2 4, this is 0, then 2 2, this is 0, then 2 1, this is 0, then 2 0, this is 1. Therefore whenever we have to calculate the 65, so this is equals to, that has a base 10, that is equals to 1 0. This is written in this form from bottom to the top. This is written as 1 0 0 0 0 0. There are 5 times 0, then there is a 1, that is base 2. Now let's see. This is this one, this is this one, this is 1's complement, like this one. This is 1 0 0 0 0 0 1. So we have calculated till this one, 1 0 0 1 0 0 1, right? This one, this zeros will be adding up for converting this into the 16 bits, 4 4 4 4. So we have calculated till here. This contains 3 2 5 6 7, only 7 bits, so the leading zeros are adding up to convert into the 16 bits integer. So this is the same example. So this is the 1's complement of this one, which is the binary equivalent of 65. So this is the way how we can convert the decimal number into the binary number. Now I have to calculate the 1's complement. Nothing else but the zeros is converted into the ones, like this one. This zeros ones, then 0 1 0 0. This becomes 1 0 1 1. This is 0 0 0 1. This is 1 1 1 0. This means this is the binary form of the 65, and this is the 1's complement of the 65. That is, whenever we have to calculate the 1's complement, that number first of all must be converted into the binary number, and then that binary number is reciprocal. That is, 1 becomes 0 and the 0 becomes 1. That is the 1's complement of any number, and the symbol that is used for 1's complement is preceded or using the symbol this one. Following program shows how to use the, or how to generate the, or how to use the 1's complement operator in the C language. This is used, that is int I j k. That is first of all there is a main function, then there is a curly braces, then there are two variables, that is declare. What are the two variables? That is the I and j and the k. So j and the k are the two variables that is declare of integer type. Now uses the, or using the for loop. So this for loop is used that contains initialization, condition, increment or decrement. So first of all there is a initialization, that is j equals to 0. Then using the condition, that is j is less than equals to 3. Then there is a increment, that is the j plus plus. Uses the, or using the printf statement. What is the printf statement? That is decimal d, that is the I, or decimal j is same as binary, this one. Then show bits, this one. That is, it is used to show the bits converted into the bits. First of all, the 0 is converted into the bits, that is 0 0 0 0 0 0. Then 1 is converted into the bits, then 2 is converted into the bits. Now using one variable, that is k, that is equal to the 1's complement of j. So whatever the bits that is stored in j, that takes the 1's complement. So the C uses the 1's complement operator, that is a tilde sign, then uses the j that contains the bits of the number. That means 1's complement is calculated, and then the output will be stored in the k variable. Right. So printf 1's complement of this is j. Then show bits k, that is show bits is used to print the value of k, because k contains a number that is equals to the, or that is equals to the 1's complement of the j. Then there is a curly brace close. So this is the curly brace that is used for the this one. Then there is a curly brace that is closed for main function. This is the closing of the for, this is the closing of the main. So the concept is, I think, clear to you. There is a 1's complement operator. First of all, we have studied how the 1's complement is calculated within a simple math language, within a computer language. Simply divide by 2, till the remainder becomes the 1 and the question becomes the 0. Then calculating, this program says that we have to convert the calculation, we have to convert the bits into the 16 bits. So we convert by using the leading zeros. So then we have studied about the how to convert into the, or how to withdraw, or how to get the ones complement. In simple terms, one complement is getting, or ones complement is calculated by inverting the bits. That is, the 0 becomes 1 and the 1 becomes 0. Right. This can be done by using the C programming. That is, we have to write the code for converting the number, or for converting the bits into the ones complement. So two variables are used, one is j and the k. J is using for displaying the in simple binary terms, that is for displaying the number in binary terms. Then k is used to get the ones complement, that is k is used to get the ones complement of the j, and the show bits is used to display the bits on the screen. So here is the output of the above program. Decimal 0 is same as the binary. This is decimal 0, this is decimal 0, is same as the binary. This is the 0 0 0 0. This is the binary representation of the 0. Now we have to calculate the ones. This is the ones complement, that is calculating by using the k. This is not j, this is k. This is misprinting, this is k. By using show bits, this is using the k. So this will be printed over here. Right. The decimal 1, that is whenever there is a j plus plus, so this is j equals to 1. Again the condition is true, 1 is less than equals to 3. This is 1 is less than equals to 3. It is displaying the binary as this one. This is the binary of the 1. Then calculating the ones complement, the zeros becomes 1 and the 1 becomes 0. Then decimal 2 is same as binary. This is decimal 2. Now again why 2? Because check the condition, j plus plus. Now j becomes 2. Check the condition, 2 is less than equals to 3. The output is, or the condition is true. Then simply printf decimal 2 is same as the binary. Using the show bits to calculate the 2 binary conversion. This is the 2 binary conversion. This is the ones complement of the 2. That is, zeros becomes 1 and the 1 becomes 0. At last decimal 3, that is same as the binary, this one. This is the calculation of the 3 representation or binary of the 3 number. Then using the ones complement, that is ones complement of 3 is this one. So this is the program that shows how bitwise operator, that is ones complement, is used. Next point says, in real life scenarios, where could the ones complement operator is useful? Since it changes the original number beyond recognition, or potential place where it is effectively used in the development of a file encryption utility. That is, this point says where it is used, that is what is the criteria why we are using this one, or where or at which place it will be used. So it will be placed, or it will be used in an encryption utility. What is the encryption utility? That is whenever we have to convert, or whenever we have to convert the data into another form that is not understood by anyone. For example, for security purpose, I convert my data into some form that is not understood by anyone, so that if the hacker can hack the data, so he or she may not able to get the data or read the data. Why? Because that data is encrypted, means that data is not in the form of the readability. That is known as the encryption. So ones complement is used in such cases, means we have to calculate the ones complement so that the data is not recognized or not readable or not understood by the hacker who hacks the data. So this is an example of encryption. There is a stdio.h, that is a header file that is used. Then there is a main function, that is the main. Then there is the encrypt function. So under main there is a curly brace close. There is an encrypt function that is used. So encrypt is a function. This is the declaration of the function. Then at the end there is a definition of the function. So here this is the definition of the function. That is a file is a keyword, pointer fs, pointer ft, then char ch. So ch is a variable that is of character type that takes only 1 byte in the memory. So in this we have defined one function. The name of the function is encrypt, right? Then it uses the fs as the file pointer for opening a file. That is done by using the fopen function. Then source.c. So source.c is the name of the file that is open in the read mode. That is a normal file. Next, ft equals to fopen. That is fopen is used for opening a file. That is target.c. So target.c is also the name of the file of write mode. That is, one is used in, or one is available in read mode, one is available in write mode. That is the encrypted file. Now check for the condition. If fs equals to null or ft equals to null, this is the sign that is used for the or. That is, either it is equals to null or either it is equals to null. Means if any one of the null, then also the output is null. Output is 0. Then check for the both for the or check the condition for both the files at the same go. If this is equals to null, this is equals to null. Then there is a curly brace. There is a printf, that is file opening error. If it is equals to null, then simply prints that there is a file opening error because nothing is nothing is contained in the file. Then exit 1. Then there is a closing brace. That means if it is if the source and the target file does not contains nothing, that is, if it is nothing is available in both the files, simply printf file opening errors. Then there is a exit 1. Otherwise, using the while loop, that is ch equals to getc/fs. That is, getc is used for reading the data or reading the data into the memory and store the output in the ch. So whatever the content that is available in fs, that is getting by the getc function, and the output is stored in the ch. Then calculating for the end of the file. That is, at the same time the getc function is used. At the same time, check the condition if it's not equal to end of the file. That is, if it is not equals to, or if it reaches to the end of the file, then simply close the file. Otherwise, puts the operation, or that is prints the operation, that is chft. What is the ch meaning? This is the ones complement of the ch. That is, whatever the data that is we are getting from the source file is merging to the ch, and the ones complement operation is performed. Then closes all the files, that is the fs and the ft. I am repeating again. First of all, uses two files, that is source.c, target.c. One is opened in write mode, one is opened in read mode. Then check for the null. If the file does not contain nothing, then simply printf file opening error. Otherwise, check the condition for the end of the file. Then uses the putc for printing the values, using the ones complement of the ch, using the ft for printing or for writing purpose. Then there is a fclose, fs, fclose, ft. How would you write the corresponding decrypt function? Would be there any problem in tracking the end of the file marker? It may be recalled here that the end of the file in text file is indicated by the character whose ASCII value is 26. So this paragraph says, in the same way what we done in the encrypt function, in the same way we have done with the, or we are also able to done with the decrypt function. So encryption means changing the data into form that is not understood by the another user, while decrypt is a function that is used to convert the encrypted data into the normal form so that anyone can use that. So encryption means converting the plain text into the cipher text, while decryption means converting the cipher text into the plain text. Now, next bitwise operator is right shift operator. So first of all takes 10 to 15 minutes break, then come back starting with this next operator, that is a right shift operator. So let's take a break for 15 minutes. Let's start with the session. So come back from the break. The second operator that is used is right shift operator, but I'm not going to start with this operator. I'm carry forward to the, or I'm molding to the, or I'm transferring to the practical approach. I'm running the programs that is available so that you get a clear idea about the programs. So let's start with the practical approach, how the programs will execute. This is the program that we made in the yesterday's class, that is used for calculating the simple interest. This is the principal amount, rate and the time. Then there is a SI that is equals to P into R into T divided by 100. Now let's see one more program for today's class. And now my target is to calculate whether a number given is even number or odd number. So even number is that number which is divisible by 0. So if I calculate, if I divide the number by 2 and if the remainder is equals to the 0, then it is a even number, otherwise it is a odd number. I am repeating again, my target is to find out whether a number is even number or the odd number. So if I am dividing the number by 2, that gives the remainder 0, that means that is a even number, otherwise that is a odd number, right? So that logic or that criteria I will be using in this, or I am using in this C program. So using hash include stdi.h, this is the header file, first header file. Then hash include conio.h, this is the second header file. Then uses void main, uses one variable that is for example a. Then printf, enter the number, that is enter the number for which you want to calculate whether it is a even number or odd number. Then scanf %d, then using or scan the number, then calculating the result, one more variable it is used, and one more nothing, using the if condition. If a modulus, what is the modulus sign? That is a divided sign. If a modulus 2 is equals to 0, this is the main condition, check it out. That means if when a is divided by 2, if it is equals to 0, that means the output is 0, that means the remainder is 0. Then printf the number is even, otherwise printf the given number is odd. There is one else, right? Then using the getch, like this one. So first of all, getting the number from the user, that is enter the number, scan the number, uses the if condition. If the when the number is divided by 2, if it gives the output 0, then printf the given number is even, otherwise, that is if it is not equals to 0, then printf the given number is odd number, then this will be closed, and then printf or using the getch for the output. Now if I compile this program, there is one error. What is the error? Misplaced else. That is, this says misplaced else. That is, we have to use the curly braces again and again for this one. That is, one curly brace is used for this one, like this one. Now let's see, there is one error, misplaced else. Unexpected error. There is a success, that means the program executes. Now there is, if I use control F9, enter the number, the given number is even, right? But if I execute again, enter the number. Why this is given in the same line? Because there is no printf statement that is used. Suppose 3, the given number is odd. So we have to apply the clear screen over here, CLR, SCR and parenthesis semicolon. If I now compile it, the screen will be 24, the given number is even. Again, if I compile it, enter the number, for example 33, the given number is odd number. So this is a program that shows how to calculate the number, or how to modify, or how to generate whether a number is even number or odd number, right? So if I save this file, this is saving option, the option is even, odd, CPP, right? What about OLESUM? This concept is clear to you? This program is clear to you? Whichever the program, you have cleared about the program? Yeah? Hello? Okay. Okay, yeah, I'm able to hear me. Okay, now let's see one more program. Now I have to calculate, I have to swap two numbers. That means when there are two numbers, for example A and the B. Now A contains 20, B contains 30. But I want the A contains 30 and the B contains 20. That means swapping of a number. That is interchanging the numbers of two variables. What are the variables? That is A and the B. A contains 20, B contains 30. But I want A contains 20 and the B contains 30. That means interchanging of the A and the B value. That program or that logic will be represented or will be used in the C language, in the C programming language. So let's start with this one. These are the header files that is used. Then there is a main function. This is also in, yes, yeah, no, this is in small letters. Then there is a void main. Then there is a space, there is a curly brace. Now I'm swapping two numbers, so I want two numbers, that is A and the B. One more number, temp. I will tell you what is the use of temp. Then printf, enter the number. That means we are getting the number from the user. In the same way, scanf, enter the another number, and using the ampersand b, right? So it is getting, or they are getting two numbers. Now I have to print the two numbers first of all. That is printf values of a and b is percentage d and percentage d, a comma b, right? Now my target comes over here, my logic comes over here. I have to use new variable, that is a temp variable, temporary variable. I have to use temp for getting the value for the time being, that is temp equals to a. Now storing the value of b into the a. Now the a becomes vacant, sorry, the b becomes vacant. Now places the temp variable or the temp value into the b. This is the logic how the swapping can be done. First of all, I have to use the temp variable, new variable that stores the data of a, that stores the value of a for the time being. Now a becomes vacant. Now put the value of b into the a, right? Now at the next term uses the temp, or now b become vacant over here. Now uses the temp and stores the value of temp into the b variable, right? Then printf, or using the printf or printing the values, printf after swapping, this is before swapping, this is value of a and b before swapping, right? This is after swapping. After swapping the value, after swapping value of a. Yes, hello. uh, yeah, this is the, okay, this is the printf, right, 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 thank you. Then uses the printf after swapping value of b is percentage d, that is b. Now using the get ch, uses the curly brace. Yeah, yes, 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 sure. Now, if I compile this program, there is a success, that is there is no error. If I execute this program, enter the number. Suppose I have entered the number as 20, enter the another number, that is for example 30. Now, this is the output. Value of A and B before swapping is 20 and 30. Now, after swapping, the value of A becomes 30 and value of B becomes 40. So this is the scenario that is used. Now I generate or I modify this in this line. This is the slash n will be used in place of against this. right? If I compile this program, there is no error. Now if I execute this program, enter the number, for example 20, enter the number, for example 30, the value of A and B before swapping is 20 and the 30. After swapping, the value becomes 30 and the value of A becomes 30 and the value of B becomes 20. So this means we have used another variable, that is a third variable, that is a temp variable, for calculating or for transferring the data or for exchanging the values of A and B. Awesome, this program is clear to you? Hello? Yeah, this program is clear to you? Hello? Yeah, awesome, this is clear to you, this program? All right. Now, uh, I think let's stop over here only because there is no other student in the today's class. So I have to shrink this class because if I go on to the next concepts, so that concept will be missed for the other students. So we would stop over here only. Let's continue with the next topic in the next class. That is the right shift operator in the next class. All right. So let's stop over here only. Thanks a lot for listening me. And now, if you have any doubts about anything, about any program, any error, then you can ask from me. So thanks a lot. That's all for today's session. Thank you so much.